Okay, so the idea of inequalities is not equal. So instead of just saying x is equal to 3, we can say x is greater than 3. And that means on a number line that the answers that work for x are numbers that are greater than 3. So we draw an arrow on 3 and up. 3, 4, 5, 6. 4 is greater than 3. 5 is greater than 3. There's an infinitely many set of possibilities. And instead of drawing a bunch of tiny dots, we draw a line to say all of them are true. 3.1 is true. 4.5 is true. 7.9. And know what? The arrow takes us to infinity, as many numbers are to the right. Now, next I want to bring up is, if you guys remember, we use a hollow symbol instead of a dot, not a solid dot. This is represented by a greater than or equal symbol. So we mentioned hollow means you're not allowed to touch it. Solid means you can sit directly on it. These are some stuff that we're reviewing from Algebra 1. Now, this is on a one-dimensional line, right? One dimension. So we're going to go into two-dimensional real quick. And today we're going to jump into 2D lines, dimensional lines. And we're going to graph this equation, y is equal to x plus 2. And I'm going to change this to a greater than symbol. So to graph this, we graph it like we see any regular line, mx plus b. And we graph it with these same ideas here. Y goes mx plus b. See, it's kicking people out. Okay, so my slope m is equal to 1. My b is equal to 2. We've done this in class already. 1, 2, put a dot. Slope is rise over run, 1 over 1. Now, we also brought up the fact that if this is greater than, let's use the word greater than, or equal to. That means not only do we have to be greater than this line that we're going to draw, but we can also be equal to it. We can be on that line. I'm going to draw a solid line on this. How would this change if this symbol was drawn this way? Y is greater than x plus 2. So take a look here. There is no greater than or equal symbol there. There's no line underneath. So how would this graph be reflected? This would be almost the same graph. Up 1, 2. The slope is 1, so rise over run, 1 over 1. But we're going to draw a dotted line instead, because we are not allowed to touch the line. Now, the next part right here, I want you guys to see, to draw a graph of inequality is actually very simple, super easy. I want you guys, everyone right now, to put your pen or pencil on the line. Put your pen or pencil on the line. So I'm putting it on the line right now. Now read this. It says y is greater than x plus 2. So which way would greater be? On top or below? Okay, put your pencil on the graph. Y is greater than. Well, isn't greater on top? And that's exactly how we shade. We put our pencil on the line and we say, well, y is greater than. That means we're on top of the line. You might try this. What if I put down here, is y greater than the line? No. Look, this, it says y is greater than the line. This is just some line. So y is greater than that line. So all the y points, as long as we're above that line, are going to give us a true statement. Let's verify this. Let's pick a point. I'll pick a point, an easy point. X is 0. X is 0. Y is 5. Right? That's a point in the shaded area. 0, 5. Would this point be a true statement for us, our line equation there? So y is 5 and x is 0. Is this still a true statement? Is 5 greater than or equal to 2? Yeah, that is totally true. If I pick another point, I'm just picking something random. Let's say it's going to be something like Negative 3, 2. Negative 3, 2. That looks like it could be there. Is negative 3, so, sorry, x and y's, right? So that's a 2 greater than or equal to negative 3 plus 2. Okay, this is my y, and this is my x. As I plugged in, is this a true statement? Is 2 greater than or equal to negative 1? Yeah. So the idea here is inequalities don't just give me one answer, they give me a whole region to play with. It's like your parents say, you guys can play on this side of the street. Anywhere on this side of the street you can play, but you cross the street and you're dead. Remember that when your parents used to tell you that? Oh, you guys can play over here, but if you cross the street, I'm gonna come after you. So it's a region, it's not just one answer anymore. Now, if we look over here to the right, I did the same thing. I drew, though, a dotted line because we're not allowed to be equal to the line. See, y has to be greater than, not equal to the line, x plus 2. So we're going to do the same thing. Put your pen on the line and ask yourself, is y greater than or less than? Y is greater than. So that's going to lead us to be on top of that line. Okay, and that's a basic principle. Now, I'm going to give you a point here that's not going to work. And we're going to take the point right here. The point is 0, 2. 0, 2 is actually on the line. This is on the line. Now, would this give me a true statement? If I plug in y is 2 is greater than x is 0 plus 2. Is 2 greater than 2? Well, no, it's not. 2 is equal to 2. So this isn't the statement. This isn't true. So that's why we draw a dotted line to, you know what, make it easy for us to see where the border is on. Where's that line that I can't cross? So that's how we're going to graph these inequalities. Now, what if it's not that simple? Well, there's some graphs that we want to make sure we pay attention to. So here are vertical and horizontal graphs. So as a review, let's graph some vertical and horizontal graphs. So if I say x equals to 3, we want to graph this on a 2D plane, x and y's. So my point right now is to remind you this idea of graphing lines when you only have one variable. If I tell you x is 3, 1, 2, 3, okay, I see 3. But did I tell you a y value? Turns out I don't care. Y could be 1, y could be 2, y could be 3. As long as x is 3, we end up with a vertical line. And that's kind of opposite what we would think it should be. We would think that should be a y line. Hey, look, I see a bunch of y's going on. But what it's really referring to is that I only care about x's. I only care that x is 3. You can be whatever y you want. Okay? So I care that x is 3. The point here is 1, 3. Oops, sorry. 3, 1. Because x is 3. 3, 2. Because x is 3. 3, 3. Because x is 3. All I care is that x is 3. To look at a horizontal line, that turns out to be that's a 2. When you have y by itself, it's almost like I'm on the second floor. Hey, where are you at? Oh, I'm on the second floor. Meet me there. Where did we park? We parked on the second floor. You guys ever, are you guys part of a family that can never remember where they park? We're on the second floor.
Absolutely.
It's a thing about me. Whenever,
have to pin where we park.
yeah, right? It's just something that no one's paying attention to. You guys must be having too much fun. So in this case, y must be 2. This is 1, 2, 2, 2, where y is 2. I don't care about what your x is. All I care about is that your y is 2. So you can think of it that way. All I care about here in x is 3. That is your x value is 3. The y value can be whatever it wants. Okay. So to put this into inequality mode now, if I say y, sorry, let's go the other way. Let's do x first. If I say x is less than 3 now, okay? So horizontal or vertical line, horizontal or vertical, we're looking at this and we're saying it's an x value. So x is 1, 2, 3. The follow-up question is, would this be solid or dotted? Solid or dotted? Well, am I allowed to be on 3? No, this has to be strictly less than 3. So we draw a dotted line. Now this is a follow-up question that isn't as hard anymore. Give me numbers where x is less than 3. Well, 2, 1, 0, all the negatives. So if you put your pen, go ahead and put your pen on the line and say which way is less than 3. When x is, well, x is less than, x is less than, x is less than 3. So we're talking about all these, this area right here, this whole region. X is less than 3. We'll do something similar over here. We'll say y is greater than or equal to 2. Y is greater than or equal to 2. So y is 1, 2. Ask yourself, is that solid or dotted? Okay. This is greater than or equal to. You might want to just say it out loud. This is greater than or equal to. That means this is a solid line on y is 2. Now, here's also another hint. Some people will make a mistake and they'll say, hey, look, y is 2. Is that really y is 2? Come on. Does that look like y is 2 to you? It doesn't. That's x is 2. Okay? So that's why we were headed in the wrong direction. Wrong direction. So over here, let's go ahead and put our pencil again on y is 2. Y is 2. Y is greater than 2. Well, y is greater. Y is greater. Y is greater. Y is greater. So we're going to be circling on top. So shading on top. Okay. Now, we want to make sure we understand that the statements that create are true or not. True or not. So I'm going to give you a problem. And we're going to test our inequalities. We're going to test them by saying, let's say 3x plus 2y is greater than 8. That's it. Give us this x and y problem. And we're going to test our inequalities. Is it going to give us a true statement? So my first point I would like you guys to test is the point 2, 1. If this is a true statement, I want you guys to plug it in. Go ahead and plug it in. Plug in the x and y. And tell me if this is a true statement or not. If it's true or not true. Okay? And if it's true, you're going to click yes. And if it's not true, you're going to click no in the participants. Okay? Go ahead and check it. Actually plug it in and see if it's true or not true. Take a moment to do that. Is 8 greater than 8? And that is not true. Why isn't it true? Because 8 isn't greater than 8. 8 is 8. 9, 10, 11, 12. Those would be greater than 8. Thank you for participating. Great job. So that's one of the things I want to make sure that you guys remember, that numbers are equal to each other, but they're not necessarily greater than each other. Like 8 is not greater than 8. 8 is 8. Imagine if you tell your parents, Mom, I need more than $10 for the movies when coronavirus is over. And your parents give you $10. They're not listening to you. Come on. But if they give you $10 and a penny, crap. But you normally say that. Give me a second. So all we do is plug in to see if this is a true statement. All right, next statement I want you guys to check is 3, 2. Is 3, 2 a true statement or not? So go ahead and check that for me. 3, 2. Thank you for those guys who were able to get the answer. Great. 9 plus 4 is 13, and 13 is definitely greater than 8. So one of the big deals is to verify our answer. And the point of an inequality, it's not to mess us up. It's to give us more options. If you guys go to Six Flags, you'll see inequalities everywhere. They'll say, if you're taller, and remember this symbol? If you're taller than this height, you are able to ride the ride. That's inequality, greater than 48 inches. But if you're shorter, you're not allowed to ride. This is no longer a true statement. But for the kiddie rides, it goes the other way. You have to be shorter than 48 inches. Because if not, you'll break the ride. And we see that in day-to-day application. When, let's say, you have 20 bucks in your pocket and you want to go grocery shopping, you have to buy less than $20. Because if you buy more than $20, you're going to look like that person in line saying, oops, anyone, let me a couple of cents, please. Okay. All right. So we make that decision all the time. The last thing is, I'm going to go ahead and rewrite this equation. So what if I want to graph it? 3x plus 2y greater than 8. So we want to graph this. And to talk about any line equation, the easiest way for us to graph is to just go ahead and solve for y. And to remind yourself that inequalities, the way we solve inequalities is we treat it like a regular equal sign. This is no different for us if this was equal to 8. There's only one thing about inequalities, is that whenever you divide or multiply across the inequality by a negative sign, we flip the inequality. And we'll do an example of that in a little bit. But let's go ahead and solve this. First step, I want to identify what variable I want to get a loan. That's going to be y, because we graph y equals 2. So we have to get rid of a 3x and a 2. So that's what's going on in my brain. My brain's saying solve for y. Now, to get y alone, get rid of the 3x and get rid of the 2. So we minus 3x to both sides. Okay, remember we're moving it to the other side. This is on my little imaginary border. 2y is greater than negative 3x plus 8. Let me do a follow-up here. We have to solve for y. We're going to divide both sides by 2. Divide both sides by 2. And I'm going to write it out this way to make my life a little bit easier, though I'm writing a little bit more. Y is greater than, I divided everyone by 2, negative 3 over 2 x plus 4. That divided nicely. Let's go ahead and draw the graph. The y-intercept is mx plus b. M is a negative 3 over 2, and the b value is 4. 1, 2, 3, 4. Put a dot. Since my slope is negative, am I going to be making money or losing money? I think I'm losing money. 1, 2, 3, 1, 2. Put a dot. And we have the follow-up question now. Would this be a solid or dotted line? Solid or dotted line? If you look here, remember, that's not equal to. That is greater than, strictly greater than. So it's going to be a dotted line. follow-up question is, would I shade above or below? Y is greater than this line. Y is greater, so put your pencil on the line. And Y is greater means I'm going to be on top. Y is greater. Okay. Now, one more thing. Thank you, Ilya. That's right, it's going to be dotted. So I wanted you guys to check one more thing for me. Remember, we picked out 2 points to test. Our first point was 2, 1. And if we go 2 steps over, 1 space up, oh my goodness, that was 2, 1. Is 2, 1 in the shaded region or is it on the dotted line? It's on the dotted line. That means it is not included. That's why it was not true. Remember, we said that was a not true statement. Our second point was 3, 2. Let's go map that out. 1, 2, 3 kind of, and then up 2. Hey, we're in the neutral zone. We're in the zone. And that reflects that these answers are in our okay area. These are our true statements areas. Okay? So we're going to do one more skill, and that's graphing 2 equations at the same time. So now we're going to look at a system of inequalities. In a system of inequalities, we're just graphing 2 separate graphs on the same graph, very similar to what we did before. But before, when we graph a system of inequalities, you guys were asked to tell me where they met, and that was the only answer. Imagine if you were on a date, and this is you, and this is your date. Okay? The only place you guys are ever going to meet is at that dot. Right? At any other point, you would have missed each other. But a system of inequalities doesn't just limit us to one answer, but a whole region, a whole scope of answers. So here we go. Y is greater than x plus, let's say x plus 1, and y is less than negative x plus 2. So I'm going to graph these 2 inequalities. Here we go. Graph the first line and the second line. Graph them separately. First line, we'll do this with blue. Second line, we'll do this with red. First line in blue. Y-intercept is 1. The slope is mx plus b. So m is invisible 1. B is 1. Just look at that. Rise 1, run 1. And then ask yourself solid or dotted. Solid or dotted. This is going to be dotted because we're not allowed to be equal to the line. Okay. We're going to graph the second line now. I'm going to draw that in red. The y-intercept here is 2. So here's 2, but the slope is negative 1 over 1. And this will be also a dotted line. Now the question is, where would these both agree? And inequalities is about, you know what, a region of answers, not just one answer. So I'm going to draw this out separately. Let's use blue first to represent the first graph. Y is greater than the line. Put your finger or pencil on the Y, okay, the blue. And then which way is greater? That's going to be up, up, up. We're going to be shading all on top here. All on top. And I would lightly shade that in your notes, just very lightly. The second one, I'll do in red. So let's put our pencil on the graph. Here's my pencil on the graph. As I'll see pencil on the graph. And Y is less than. That means down, down, down. Please, some of you guys might think like down might be this way. Don't think of it that way. Just go straight down. Straight down, 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 down. Down, 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 down. And I'm using colored highlighters here. And it's obviously only one place that's circled twice. or highlighted twice. So it turns out the region that is true for both statements, is I am true. This statement here is I am true for both sides. If you pick any point here, it would be true for the top equation and the bottom equation. And that's actually the only reason that would work. Any other point would be false for one of these people. This is a place where we could say this is common ground. This is where we can all agree. Okay, so let's go ahead and take a look at the Excel, and we'll see how that's operating today. So here's another way of graphing the same exact thing, except without color pencils or anything. So I drew my first line, second line. Let's draw that line again. 1, 2. Now you just have to keep the line straight. This was in your head. Y is greater than x plus 1. And oftentimes people will label it so it doesn't confuse them. Second one is y is less than negative x plus 2. Now I'm going to show you a super fast way of doing this. Super fast. It takes you not even a second, okay? If the first line here, take a look at the first line. If y is greater than, put your pencil on the mark. Y is greater up here and up here. We only have 4 points to pick from. So the 2 points that work are everything. You could shade it. But you know what? That's going to be a waste of your time. Just put a mark. Those 2 sections are above my first line. Now look at the second line, okay? Second line time. Of the remaining sections, here are the remaining sections, okay? Which of these sections are, of the remaining, we only said these 2 are true. So for my second line, of these 2 sections, which of these are less than the y? Of these 2 sections here, right? Which of these are less than y? Only this guy. So on your homework, if you just draw this, that's 100% okay. But you should give yourselves little marks just to remind yourself what part is okay. If you can also say, hey, look, if one is a vertical line, the second one is a horizontal line, hey, look, they both agree. Okay, just for little notes, mental notes for yourself. The last thing here is just a rule reminder. Whenever you multiply or divide across an inequality, if I write negative 3x is less than 9, we're trying to get rid of the negative 3. If we divide both sides by negative 3, please remember in algebra, this will be on the SATs in case you make a dumb mistake. When I divide across by negative, you flip the inequality. Now, here is how you remember that. Let's say you're taking a test 2 years later and you forget the rule. So give me a number that works here. Any number you want. Hey, doesn't 0 work? If x is 0, that is a true statement, right? 0 times 3 is 0. 0 is less than 9. But if I went ahead and tried solving it, and I forgot the rule, and I wrote instead x is greater than negative 3, right? I moved the 3 over. So you can see, whoops, I automatically wrote the right answer in my head. Okay, what if I write this? Is 0 still going to work? No, now it doesn't work anymore. So all of a sudden, I broke it. But if you look here, if I remembered, okay, to flip it, hey, 0 is greater than negative 3 and would still stay a true statement. What happens is if you forget the rule, you can make up the rule. Do I flip or do I not flip? Just plug a number that worked beforehand, and that number should still work afterwards. And that's just a quick way to remind yourself that if you do forget the rule, you can always make up the rule. Answers that work beforehand should work afterwards too. So let me show you this real quick. Just to show you. In this original question here, give me a number that works besides 0. If I pick -2, okay, -2. -2 times -3 is 6. Is 6 less than 9? Yes. Now, look at my answer. Is -2 greater than -3? On a number line, yes. -2 is greater than -3. It's on the bigger side. Okay. Just as a quick reminder. So whenever you divide across or even multiply across by a negative, you must flip that inequality.